Hey guys, you're watching Python tutorial videos on my channel Python for Microscopists on YouTube. This tutorial is a continuation of our discussion about openCV for image processing. And in this tutorial, let's actually talk about histogram equalization and also image thresholding. And histogram equalization is again one of the tools that we have for image pre-processing. So our image thresholding or segmentation task becomes a bit easier. Now, the reason why we need histogram equalization is, for example, if you collect images that look like they're washed out, oftentimes we collect very low contrast images on microscopes for whatever reason. It could be the nature of the sample. Sometimes it's just that we haven't set up the brightness and contrast settings on the microscopes properly, or sometimes they just drift. Yeah. So whatever the reason, with histogram equalization, you can stretch the histogram to span the entire range. Let me give you a quick example here. I want to show you an image of, let me open this, of an alloy that's collected using a scanning electron microscope. It could also be a light microscope in a reflective mode, for example, or a biological sample. It doesn't matter. Here, we can kind of see the separation between these two regions, but it's not as good as it could be. So let's go ahead and load this image, look at the histogram, and then use equalization to stretch the histogram and then threshold it or segment it. So let's get into our Spider IDE, which is again part of Anaconda distribution. And I believe I'm zoomed in enough so you can clearly see what I'm typing. So I type with import CV2, line 1, import numpy as NP, always my line 2, and from matplotlib import pyplot as PLT because it has a lot of plotting functions and I would love to use it. These three lines are almost standard, and plus maybe scikit-image if I'm using some functions or some modules from scikit-image. Now let's go ahead and read our image. I'm assigning my numpy array, which is nothing but my image, to a variable called img. And the way we read is cv2.imread, and my image is under images and it's called alloy.jpg. And let's read this as a gray level image. I typed 0, which is gray level. If you type 1, that's color image. Performing histogram equalization is nothing but I'm assigning a new variable eq underscore img and cv2 dot, I think it's eq, equalize hist with h in uppercase. And what are we doing with our image? Okay, so I'm performing a histogram equalization on my image. So let's go ahead and look at our histogram first for our image and then for our equalized image. So image.flat, nothing but flattens our 2D array for our image into one dimension, so I can look at the histogram. And let's do 100 bins, and let's do range equal to 0 to 255, and let me go ahead and run this. And the histogram, as you can see, is skewed towards the right here, which let's hope histogram equalization fixes. So let's, we already did the equalization, so let's go ahead and look at underscore img, and let me run this, and we should see that it actually stretched it all the way from 0 to 255. Okay. So this is histogram equalization. In fact, let's go ahead and look at our plt.imshow, or actually let's use cv2.imshow. I like this better because I can see it in a much bigger window. And this is equalized image, let's say. And what do we want to see? eq underscore image. Now every time, again, it's worth repeating, when you do cv2 imshow, always do cv2.wait, uppercase K, wait key, and 0. This means it waits forever until we close the window. and then CV2 after we hit the close, destroy all well, we probably don't need this, but let's leave this up. Destroy all windows, and that's it. So let's go ahead and run this so we can actually see our histogram equalized image. And here is the equalized image, and we saw the original image is right there. Okay. Again, there is a lot of noise in the equalized image because it stretched the histogram. There is a lot of noise right there if you look at it. So histogram equalization considers the global contrast of the image, not just the local contrast. Also, in this case, it's probably okay, but if you have things changing, in your image, on one side you have something, on the other side something else, performing a global equalization may not work very well on your images. So there is something called adaptive histogram equalization. So that is amazing. I mean, let's go ahead and do that in a minute. So all it does is it does this histogram equalization in small patches or in small tiles. Okay, so it actually works very well, and also it does contrast limiting. And in this specific algorithm does contrast limiting. So it's called contrast limiting adaptive histogram equalization, CLAHE. This is the CLAHE based histogram equalization. Again, contrast limited adaptive histogram equalization. So how do we perform that? So let's insert this one line right here. Well, actually this is two lines. So let's assign this to a variable called CLAHE. This is create. We need to create this first. I believe this is create CLAHE, and we need to give the limits, of what is the clipping size, for example. So in this case, let's just say clip. I'm cheating here on the other screen. I have like documentation about it. Go ahead and look at it. So I always mess up the uppercase and lowercase. So I always have the documentation to see what the parameters are that actually go into this specific function. Otherwise, it's a waste of time. So clip limit, and let's just do 2.0. Again, look at the documentation of what that value means. And this is more important for now. Grid uppercase S, I believe, yeah, equals to, and let's just do 8x8 grid. Okay. So now I defined what CLAHE means. Now I need to apply that onto my image. Okay, this is how you apply. Let's call this CL IMG. Okay, so this is my new variable, and what is this? This is nothing but CLAHE applied to apply to my image. Okay, so I'm taking my original image and applying this CLAHE, and now we can just look at it. Okay. And let's compare both images. ImShow, this is not CLAHE image, so let's just do which is CL_IMG. Okay, now let's go ahead and plot this, and now you can see that this is CLAHE image, and on the left I have the equalized image. So this one is not bad. This is actually much better compared to this other one where we have. This image also still has a lot of noise. So let's see how our thresholding works out. In fact, the original data set itself is not very clean. So we'll see how this works out. This is nothing but, again, I did a Google search and downloaded this. So, and also this is in JPEG format. I think image formats deserves its own different tutorial. I'll see if I can cover that. But the last thing you want to do is work with JPEG images. Maybe save images as TIFF file format. That's the one quick thing I can say as part of this tutorial. So this is how you perform your pre-processing. So let's actually settle on, let's remove this histogram equalization. Let's settle on, not settle, let's decide that we would like to use CLAHE. So let me go ahead and delete these, and now let's see if we can threshold this image now that we have a clean image. well, not a clean, but a histogram is easy enough for us to threshold it. So by looking at the histogram, in fact, I shouldn't have deleted this line about histogram. So let me go ahead and undo that. Equalized image, let me delete it. Histogram, let's go ahead and plot the histogram right here, except it should be CL underscore image. So let's run these lines so we can have a look at our histogram. And there is my histogram. Again, it's going from 100 to 250. Somewhere in the middle, we seem to have like a dip. In fact, let's look at, instead of 0 to 255, let's look at 1,000 to 255, so we can identify this region slightly better. So where is my histogram? Looks like 180, 200, about 185 or 190. Let's say about 190 is where it's a good place to separate these two peaks. So now let's just do our histogram segmentation. Let's clean up this. And how do we do thresholding? Again, our segmentation, if you want to call this. Here in openCV, it's cv2.threshold. Okay, so let's do return thresh1. So this is the thresholded image. Ignore the first argument first. We need to unpack both, otherwise it's going to throw an error. So I'm going to just put a dummy like RET right there. CV2 threshold. What do we want to threshold? We want to threshold CL underscore IMG, right? That's the image that we have here. And what is the first parameter? Again, I'm looking at the documentation. The first argument is the image, which should be the gray level image to use this threshold. And the second argument is the threshold value. So we identified 190 as our threshold value. Now, once it's thresholded, what value do we want to give to all the pixels that are thresholded? Let's give a value of 150. It can be any value. Well, if you give 0, you won't be able to see it, but then it will still be segmented, okay? And using what method, yeah, is the next one. cv2.thresh underscore binary. Yeah, there are a few other ways of thresholding. I mean, there is binary, there is, I don't even pretend I know all of those. Look at the documentation. So this is our threshold one. Let's also threshold the other one. Yeah, there are two phases. So because we have two phases, it's easy. The other one can be just the inverse of the first one, right? So let's just do threshold of threshold 2, which is equals to CV2. Let me just copy the whole thing. Control C, Control V here. And I'm going to leave the same value, 190, except once it's thresholded, I want to assign a value of 255 and inverse here. Okay, so we are just inverting the threshold here. So all thresholded pixels in white, all thresholded pixels here in whatever that gray level corresponding to 150. That's it. Now let's look at, instead of equalized image, let's look at our original image first, okay, which I think we called it IMG. And then let's look at our, I'm thinking what I should be calling, let's just call this binary threshold 1, which should be our THRESH1. And let me copy this line again. And this will be our threshold number 2, or I could have called it inverted threshold number 2. And let's go ahead and plot this. So this is the original image. This is the thresholded image 1. Look, all the gray levels here are have a value of 150, and this is the thresholded image 2. All the values here are 255. We could have done slightly better job, but I think with this is nothing but histogram-based thresholding, right? Binary thresholding using histogram. I went through similar exercise using scikit image, and this is pretty much the same thing using openCV. And some of the stray pixels here and some pixels here are gone. Some pixels here showing up, some stray pixels here, which is fine. So this is it. This is how easy it is to do segmentation. If it is a binary segmentation, if it is multiple, just do multiple thresholding and you kind of have your multiple thresholds. Now, one thing is in this example, we found out that 190 is the best value by looking at our histogram, but there is an easier way. Again, I covered Otsu based thresholding in one of my previous tutorials when we talked about scikit image. Let's do exactly the same thing in openCV. So what the way to call Otsu is, again, I think it's we just need to change this last line. So let me look at the documentation again. So let's call this I don't know, RET2, and this can be THRESH3. Okay, let me just delete this and let's call this, okay, threshold 2, maybe THRESH2 equals CV2. In fact, it's better if I copy this line, except okay, CL image, and now I want to go all the way from 0 to, you know, and assign a value of 255, and this is CV2 dot thresh underscore binary plus CV2 dot THRESH underscore OTSU. Okay, so this is how we apply our Otsu based thresholding. Let me zoom out a little bit. So all we are doing is threshold 1. This is nothing but just the binary. I'm leaving it so we can compare it. But if you just want to do Otsu based thresholding to automatically to automatically segment this, then this is the line. That's it. So threshold your image going all the way from 0 to 255, because my CL image is a unsigned integer 8, which is that's got values from 0 to 255. So 0, and then all the segmented pixels I want to label them 255, and CV2 threshold binary plus CV2 threshold Otsu. So now if I just do threshold 2, and instead of binary threshold 2, let's just call this Otsu. I think we got everything. So let's go ahead and run this, and my Otsu image is right here. So this is pretty much the same, as you can see, almost the same. Now, well, let's actually look at our Otsu threshold value. In fact, all the Otsu does is it actually comes up with a with this value automatically. You know, the best value for separating these two phases. It actually comes up with that automatically. So I bet we can have a look at it right here. So if you look at the RET2 here, look at the RET2, it says 181. This is nothing but the threshold value that Otsu is defining, or it found that the best place to separate this data set is at 181 pixel value. In the previous one, when we did our own thresholding here using histogram, we ourselves defined the value to be 190. Okay, I hope this is not confusing. Otsu, if you have binary thresholding, is the best way. It finds the best place to separate these two data sets. Okay, if you want to get fancy, you can also use k-means and then do all kinds of fancy stuff, which hopefully we'll get to at some point later on. So so this is it. And one other thing that I'd like to, I have some notes here about what to show. It's already 18 minutes, so I'm not going to show this because I've already covered this in my previous topics. If your image is noisy, do not forget to denoise it first and then do all of this exercise. Otherwise, your life can get pretty difficult. Otherwise, let me run this again. Otherwise, what's going to happen is there will be a lot of salt and pepper, just like we see that here. There will be a lot of that going on in your image, and your segmentation will not be ideal. Okay, so again, the summary of this is the CLAHE based histogram equalization works great on most situations. And once you do that, then you can use your histogram to threshold or segment your images into, in this example, into these two phases. But If you don't want to plot the histogram and identify the separation, where to find that spot, the sweet spot for separating these two regions, then Otsu would be a great way of doing that. It automatically finds the regions and it automatically thresholds the entire image. And and that's pretty much what I plan on covering for today. In fact, I had another topic, but I'll split this into another video. It's already 20 minutes. I hope you found this tutorial to be useful. And again, please go ahead and subscribe to this channel so it keeps me motivated to make more and more videos that are helpful to you. And let's talk another topic in our next tutorial. Thank you very much.